All right, first question, we have integral of cosine of x dx. You just have to memorize all of these. They should be on the chart I gave you guys. This one is just C. Next up, we have a limit as x approaches 0. And a lot of times on these limits, I'm starting to think about L'Hopital's, but you always want to just plug in just to make sure. So I'm going to plug in 0 anywhere I see an x, and that is 0 over 0. So we are going to be doing L'Hopital's. So L'Hopital's just says take the derivative of the top and the bottom separately. So this is the limit as x approaches 0 of 12x to the 5th plus 18x squared over 20x to the 4th plus 9x squared. And this is actually going to be 0 over 0 again. We're going to have to do L'Hopital's quite a few times. We get the limit as x approaches 0 of 60x to the 4th plus 36x over 80x cubed plus 18x. This is going to be 0 over 0 again. Then we'll do it another time. The limit as x approaches 0 of 240x cubed plus 36 over 240x squared plus 18. And this will be 0 plus 36 over 0 plus 18, or 36 over 18, which is just 2. You also could have done this factoring, and factoring actually would have been a lot faster. So had you factored out like a 2x cubed, that would have been faster on top, and then you could factor out a x cubed on bottom. Either way will work. All right, next up, we want to figure out a value k to make this function continuous. So if it's continuous, then we know if we plug in x as 2, both of these should be equal to each other. So basically 2 squared minus 3 times 2 plus 9 should equal to k times 2 plus 1. So that's 4 minus 6 is negative 2. Negative 2 plus 9 is 7. Should equal 2k plus 1. Subtract 1, divide by 2, and we get k equals 3. All right, next up we have a chain rule question. And this one we can rewrite as cosine of 4x all cubed, like the cubed is kind of our outside. So this is like kind of having like box cubed, right? This is chain rule, so we're going to bring that down. It's going to be 3 times our box, right? Cosine of 4x squared, and then times, so that was the derivative of box cubed. Now we have cosine of box. So the derivative of cosine is negative sine of our box, right? And then finally we have times the derivative of the little box, so times 4. So I'm going to multiply 3, negative, and 4, put that in the front, so negative 12 cosine of 4x squared, I'm going to put the squared there, times sine of 4x. All right. And so that should match up with B. All right, next up we're finding a relative minimum. Anytime we're doing a relative minimum, we always start off with f prime of x equal to 0. So f prime of x here is 6x squared minus 6x minus 12. We're going to set that equal to 0 because we're finding a relative minimum. Factor out a 6. Two numbers that multiply to negative 2 add up to negative 1 would be x minus 2 and x plus 1, which is going to give us x equals 2 and negative 1. To figure out which one is a relative minimum, we're going to do f prime, do a number line analysis, negative 1, positive 2. I'm going to plug in, say, negative 3. Negative 3 minus 2 is negative. Negative 3 plus 1 is negative. Negative times negative is positive. Plug in 0, I'm going to get negative and then positive. And plug in 3, I'll get positive and positive. So this is increasing, decreasing, increasing. So we get a relative minimum here at 2. Okay. Next up, we're asked for a tangent line, and this is going to be x1, y1, and m. This is a little bit of a complicated tangent line question. The x1 is 1. To get the y1, we're going to plug that into the original. So this is 2 times 1 minus 1 to the 5th times 1 plus 1. That's 2 minus 1 is 1 to the 5th is 1 times 2, which is just 2. Then to get the m, first we need to take f prime of x, and this is where it does get a little complicated. This is going to be a product rule. You could do Pascal's triangle and then FOIL everything out, but that would be a lot of work. It's a lot easier to just do product rule here. So the first one is kind of like having box to the fifth, right? If I have y equals box to the fifth, y prime is 5 box to the fourth times the derivative of the box. So this is going to be 2x minus 1 to the, 5, bring the 5 down, 5 times 2x minus 1 to the fourth times 2. And then we're going to leave x plus 1 alone. Then plus, now we're going to leave 2x minus 1 to the fifth alone, times the derivative of x plus 1 is just going to be 1. So to get m, we're going to just plug in 1 to that. All right, so 5 times 1 minus 1 is 1 to the fourth is just 1, times 2, that's 10, times 1 plus 1 is 2, plus 2 minus 1 is 1 to the fifth is 1, times 1. So this is going to be 20 plus 1, so 21. Now if I look at these, I know it's got to be a or b, but it is easy enough to solve this. So y minus 2 equals 21 times x minus 1. These are all solved for y, so we're going to just put this back into y equals mx plus b. So y minus 2 equals 21x minus 21. Add the 2 over, that's going to be 21x minus 19. All right, next up we have the integral of e to the x. This is one you just memorize. It's a very, very easy integral. The integral of e to the x is just e to the x. Don't get confused and try to do like e to the x squared over 2 or anything like that. The integral of e to the x is just e to the x. From 0 to 1, this is e to the 1 minus e to the 0. E to the 1 is just e, and e to the 0 is 1, so this is just e minus 1. All right, next up we have a trapezoidal sum with 3 subintervals, and it says that when we take the trapezoidal approximation, that equals 52, and they want us to find the value of k. So essentially what we're doing is we're saying the integral from 0 to 6 of f of x dx, we're going to do the trapezoidal approximation, so that's width of 2 times 4 plus k over 2 plus width of 2 times k plus 8 over 2 plus width of 2 times 8 plus 12 over 2. And when we do this approximation, the answer is going to be 52. Then we're just solving for k. I'm going to go ahead and just cancel out all these 2's, make it a little easier for us. And so this is just 4 plus k plus 8 plus 8 plus 12 equals 52. I have 2 k's. And then 4 and 8 makes 12, plus another 8 makes 20. That's plus 32 equals 52. That gives me 2k equals 20. Divide by the 2, and we get k equals 10. All right, moving on, we are given a particle moving along the x-axis with a velocity of v of t equals 4 minus 6t squared. The particle's at position x equals 7 at time 1. What is the position at time 2? So if I'm going position, velocity, acceleration, I have velocity, I want the position, that's an integral. Right? They gave me velocity, and I want position. Oops. So I'm going to write v of t equals 4 minus 6t squared. Take the integral with respect to dt. Oops. And the integral with respect to dt. The integral of v of t is going to be x of t equals 4t minus 6t cubed over 3 would be 2t cubed, and then plus c. They tell us that the position is 7 at time 1. So for x, I'm going to put in a 7. And then anywhere I see a t, I'm going to put in a 1. That's going to be 7 equals 4 minus 2 is 2 plus c. So 5 equals c. So now I know I have x of t equals 4t minus 2t cubed plus 5. And so I wanted x at 2, right? That's what they asked, the position at time 2. So that's 4 times 2 minus 2 times 2 cubed plus 5, that's 8 minus 16 plus 5, negative 8 plus 5 is negative 3. There is an alternate way to do this. We'll learn this a lot more next semester, but it's basically this alternate form of FTC. So the integral from a to b of f prime of x dx is equal to f of b minus f of a. So there's an alternate form which basically adds the f of a over, and then you just switch sides. So f of b equals f of a plus the integral from a to b of f prime of x dx. And you can use this with position and velocity. So because position is the antiderivative, it is the integral, you can essentially write that x of 2 would have to equal x at 1, which is 7, plus the integral from 1 to 2, that's my fault. Right, those endpoints, that's a, that's b, of x of t, or sorry, v of t dt, so 4 minus 6t squared dt, and then you would take that integral with endpoints and add on 7, and you should get the same answer. If that makes sense to you, go ahead and use it. If it doesn't, don't worry about it. We'll focus on that second semester. All right, so next up we're given a graph, and they tell us that the function is given by ax squared plus 12 over x squared plus b, and which of these could be values for a and b. So this has a horizontal asymptote and a vertical asymptote, and so we need to kind of use that information to help us out. So in order to figure out a, we can see this graph has a horizontal asymptote at y equals 3. Right, that's this one. Right, and so that's top heavy, bottom heavy, equal heavy, right? That's how we find our horizontal asymptotes, is top heavy, bottom heavy, equal heavy. Well, this one is equal heavy. And so we basically know that ax squared over x squared, the x's should cancel out, and that should be equal to 3. So there's nothing on the bottom, it's like a over 1. So that tells me that a equals 3. So I can get rid of these ones. Now to get b, that's a vertical asymptote. So this vertical asymptote, we get those when the denominator equals 0. So that means x squared plus b has to equal 0 at x equals 2, right? That's where this is happening, is at x equals 2. So that would be 2 squared plus b equals to 0. So 4 plus b equals to 0. So b is negative 4. All right, what is the slope of our tangent line to the graph at x equals 1? Slope of a tangent line, always when we see that, that just means take the derivative, plug it in. So we're going to do y prime equals, this is quotient rule, so low, x plus 1, d high, e to the negative x times negative 1. There's a chain there, right? E to the box. Then, so it's low d high minus high d low. Derivative of the bottom is just 1, all over low squared. Now I can just plug in 1 anywhere I see an x. So this is going to be 1 plus 1 is 2 times e to the negative first times negative 1 minus e to the negative first times 1 all over 1 plus 1 squared. That's going to be 2 squared, so 4. This is going to equal negative 2 over e. Right, I'm going to just write over e because I have e to the negative first. Then minus 1 over e all over 4. If you look at your answer choices, none of them kind of look like this. We have a fraction inside of a fraction, so I'm going to go times e, and times e. That way I can get rid of that little fraction in the fraction. And that's going to be negative 2 minus 1 over 4e, which is negative 3 over 4e. All right, next up we have a graph for x is greater than or equal to 0. The horizontal line y equals 2 is an asymptote. Which of these following statements must be true? So horizontal line is an asymptote. That's always a limit to infinity. You want to remember vertical asymptotes are when the denominator is equal to 0. Horizontal asymptotes is the limit out to infinity or negative infinity. That's the top heavy, bottom heavy, or equal heavy. So this is just e. If you do go ahead and graph this, y equals 2, right? We don't know anything else about the graph. All we know is that, you know, for x is greater than or equal to 0, that's the positive side. it's going to go there. It could do anything here. It could, as long as basically it approaches from either side there. So as we go out here, that is the limit as x approaches infinity of f of x being equal to 2. So if you graphed it, I suppose you could also figure it out. But the better way to think about this is just realizing horizontal asymptotes, we know those are limits as x approaches infinity. Or negative infinity, we do top heavy, bottom heavy, and equal heavy. And then vertical asymptotes occur when our denominator, we're going to set the denominator equal to 0. All right, we have another integral question. This one is not in polynomial form, so in order to solve this, we have to expand it out, FOIL it out, and get it into polynomial form. I like the shortcut. The first one squared, x cubed squared is x to the 6th, plus multiply them together and then times by 2. So 2x cubed, then plus the second one squared is 1 dx. Now, if you can't do that in your head, you could also just do x cubed plus 1 times x cubed plus 1 and FOIL that out. And you should get this exact same answer. So once we have that, this is x to the 7th over 7 plus 2x to the 4th over 4 plus x plus c. I'm going to write this as 1/7 x to the 7th plus this is going to be 1/2 x to the 4th plus x plus c, choice B. All right, we have the limit as h approaches 0. So we have a limit question, and if you plug in 0 here, you are going to get e to the 2 minus e to the 2 over 0, which is 0 over 0, but this is not L'Hopital's rule. When you see these h's in here, you want to remember this is actually the definition of the derivative. Okay, you can't really do L'Hopital's here. You have to realize the definition of the derivative. So this is like basically saying f of x equals e to the x, right? Where you see that 2, that's an x. And then we want to find f prime of 2. So first we're going to find what is f prime of x. Well, the derivative of e to the x is e to the x. Then plug in 2. So f prime of 2 is equal to e to the 2.
All right, for limit approaching infinity questions, you look for top heavy, bottom heavy, or equal heavy. Since this question has x to the power of 3 on both the numerator and the denominator, you kind of just ignore everything. You just cross everything out, and even this gets crossed out, and you just look at the coefficient of the highest x value. So this is technically a 1 here, so this is equal to 1/4, which is C.
All right, next up we have f prime of x equals the absolute value of x minus 2, which the following could be the graph of y equals f of x minus 2. Don't pick A. A is f of x equals the absolute value of x minus 2. But we want y equals f of x. So you can actually look at A and kind of realize, hey, this is the f prime of x graph. So this graph is always positive, right? And we know that about an absolute value graph. It's always positive. What that means is that if f prime is always positive, then f is always increasing. So B can't be correct because it decreases then increases. C can't be correct, right? There's a decreasing section. So it's either got to be E or it's got to be D. Now, if we look here at x equals 2, that derivative does not exist, right? So E is not correct because E has a 0 there, whereas D would be correct because we do have a does not exist there. So it's increasing, continues to increase with a does not exist, kind of a jump there. All right, 17, we have the integral of sine, which is cosine of x from 0 to pi over 4. This gives us cosine of pi over 4 minus cosine of 0, which is rad 2 over 2 minus 1. So choice E. 18, for the function f prime of x equals 2x plus 1 and f of 1 equals 4. What is the approximation using the tangent line? So we're going to do x1, y1, and m. x1 is 1. y1 they gave us was 4. For m, we're going to plug that into the derivative. 2 times 1 is 2, plus 4 is 5. So y minus 4 equals 5 times x minus 1. Then we're going to plug in 1.2 where we see x to get the approximation. So y minus 4 equals 5 times 0.2. 5 times 0.2 is 1. So y is approximately equal to 5. I think I messed that up there. 5 times 0.2. Yeah, I see my mistake. 2 times 1, when I plugged in 1 here, right? 2 times 1 is 2. 2 plus 1 is 3. So this should have been a 3. We should have had a 3. So 3 times 0.2 is 0.6. Add 4 over, we get 4.6. All right, 19, we have the graph of f of x is x cubed minus 6x. We want squared, we want concave up. That's second derivative. So f prime of x, 3x squared minus 12x. F double prime of x, 6x minus 12 equals to 0. 6 times x minus 2 equals to 0. X equals 2. All right, make a number line. F double prime, plug in a number like 0. 0 minus 2 is negative. Plug in 3, you get positive. Concave down, concave up. So this would be when x is greater than 2. All right, we have a polynomial function with degree greater than 2 if a is not equal to b and f of a equals f of b equals 1. Which of the following must be true for at least one value between a and b? So in this case, we have f of a equals f of b, which is equal to 1. This is a big hint. Polynomial tells us it's continuous and differentiable. This is a big hint that we can use Rolle's theorem. Right? So for Rolle's theorem, we know that f prime of x equals 0. We know that is true. Now, we don't really know if this graph ever actually does touch 0. We know that f of a is 1 and f of b is 1. But it just says degree greater than 2. If it was odd, we would know 1 has to go up and 1 has to go down. But we don't know if this is odd or if it's even. So this graph hypothetically could just do something like this, right? And never hit 0. And this would be concave up the whole time. It never hits 0. So we don't know if this is true. However, it does say degree greater than 2. So if it's a degree greater than 2, it can't just be a straight up parabola. So it might have to make another turn and do this. So we know that at some point f double prime of x has to be 0 because the degree is greater than 0. This one was a little tricky. So this one is actually 2 and 3, which I don't see as an option. So I'm going to just go with 2 only here. I think that maybe hypothetically what they're kind of getting at is you could have some kind of a DNE that would have to have an absolute value polynomial function. They didn't really say that, but I'm guessing that this they're going to say is not true. And they would go with 2. This is honestly not a great question. This was not an AP question. This was something I got from a review textbook. Oh, you know what? This is actually why I see this. Okay, it says for at least one value between a and b. So that's why it's 2 only. So this must be true, like if we think from negative infinity to infinity, right? Because they told us the degree is greater than 2. So somewhere, we do have to change, but it doesn't have to change between a and b. Between a and b, that's the Rolle's theorem, right? This f of a equals f of b equals 1. That's telling me that somewhere in between those two values, there has to be an f prime of c equal to 0, right? It doesn't tell me anything about f of x or f double prime of x, just f prime of c. All right, we have the graph of f prime. If f of 0 equals 5, then what is f of 1? So this is the graph of f prime. To get from f prime back to f, we need to take the integral. So this is basically saying the integral from 0, right? These are our limits, our endpoints. So the integral from 0 to 1 of f prime of x dx equals to f of 1 minus f of 0. To get this integral, that's the area of this triangle. So that's 1/2 times 1 base times height 6 equals f of 1 minus 5. Half of 6 is 3. Add the 5 over, you're going to get 8. All right. We have this f prime of x equation, and they say which of these would be a relative extrema. So to get a relative extrema, we're going to set this equal to 0. That's going to give me x equals 2, 3, and 4. There is a shortcut for this, but I'm going to just kind of do it this way. So if I plug in 0, I'm going to get negative. Negative squared is positive, and negative cubed is negative, so I'll get a positive. If I plug in 2.5, I'll get positive, negative, but square is positive, and then negative. If I plug in 3.5, I'll get positive, positive. 3.5 minus 4 is negative. Negative cubed is negative. And then 5, I'll get all positives. The shortcut is it's going to change everywhere except for at 3 because that was the one that was even. Okay. So a relative maximum at 2, that is a maximum. A relative minimum at 3, that is wrong because that's neither. And then a relative maximum at 4, that's wrong, it's a minimum. So this would be 1 only. All right, we have 4 line segments. It says which statement is false. This one is a little tricky, but we'll go through it. The limit as x approaches 0 of f of x minus f of 0 is 0. So that is true, right? When you plug that in, you're going to get f of 0 minus f of 0. Okay. Next one, f of x minus f of 0 over x. And this one could be like kind of x minus 0. So this is basically the definition of the derivative at x equals 0. Right? And the derivative here is dne. So this one is false. When I look at the other ones, the limit is f of x minus f of negative x. So this would be f of x minus f of negative x over x minus negative x. This would be the average rate of change between like a positive x and a negative x. Well, this graph is symmetrical, so that is true. Okay, this next one is the derivative at x equals 2, 1, 2. The derivative here is 1. And then the last one is the definition of the derivative at x equals 3, and this one does not exist because we make a corner there, so that is also true. Right, so B was the definition of the derivative at 0, which should have been dne. All right, the radius of a circle is increasing at a certain instant. The rate of increase in the area of the circle is equal to twice the radius of its increase of its circumference. So we have basically dA dt is equal to twice the rate of increase in its circumference. So this is going to be the pi r squared, right? Area is pi r squared. So the derivative would be 2 pi r dr dt equals circumference is 2 pi r. The derivative that would be 2 pi dr dt. So the pi's cancel out, the dr dt's cancel out, the 2's cancel out, and we get radius equals 1. All right, we have an implicit. So this is product rule. 2x, leave y alone, plus x squared, take the derivative of y is dy dx, minus 3 equals 3y squared dy dx. I'm going to plug in anywhere I see an x, I'm going to plug in negative 1. So this is negative 2. Anywhere I see a y, I'm plugging in 2. So negative 2 times 2 is negative 4. Plus negative 1 squared is 1 dy dx. Minus 3 equals 3 times y squared, that's 12 dy dx. I'm going to solve. Negative 4 minus 3 is negative 7. Subtract the 1 over equals 11 dy dx. Divide by 11, we get negative 7 over 11. All right, for x is greater than 0, we have f prime of x equals ln of x, and f double prime equals 1 minus ln of x over x. Which of these must be true? F is decreasing when x is greater than 1. So basically, on here, these words like kind of decreasing, increasing, and then concave down and concave up. We're going to take f prime of x and then f double prime of x, set them equal to 0, and dne. So f prime of x is ln of x over x. When we set this to 0, and dne, that's going to be like setting the top and the bottom to 0. So the top, ln of x equals 0. Take e to the both sides. And then that's going to give us x equals e to the 0, which is 1. Then we'll do the bottom to 0, x equals 0, that's just 0. So for my critical points, we get f prime. We have 0 and 1. And so we would be, if I plug in a negative number, well, negative number is not going to work at all, and it's just for x is greater than 0. The reason it's not going to work, we can't do ln of negative, so this is going to dne. So between 0 and 1, like 0.5, ln of a number smaller than 1 is negative, and then 0.5 is positive. So that's a negative, and then ln of a number bigger than 1 is positive over a number bigger than 1 is positive. The way that I got that, so to remember that, you basically just need to memorize the graph of ln of x. So the graph of ln of x at 1 is 0. And so basically anything that we take the ln that's bigger than 1 is going to be positive. Anything where we take the ln that's smaller than 1 is going to be negative. Right? Those negative values, those are positive values. All right, so this says f is decreasing for x is greater than 1. That's wrong. F is decreasing for x is greater than 1. That's wrong. F is increasing for x is greater than 1. Either of those could be right. And f is increasing between 0 and e. That's wrong. So we at least turn that down to a 50-50. Now for the concave up, concave down, we're going to take the second derivative of x, set that equal to 0 and dne. We're doing 0 and dne because we have a fraction. So 1 minus ln of x equals to 0. That's 1 equals to ln of x. We'll take e to both sides. That's going to give us x equals e. Then we can also do the bottom to 0. X squared equals 0, so x equals 0. So for concavity, our two critical points for f double prime are 0 and e. And actually, if we're a little bit smarter about this, instead of doing arrows on the left, we can actually kind of do this as a bracket on the left. Right, because it's going to just start at 0 or stop there. So if I pick a number smaller than e, like say ln of 1, ln of 1 is 0. So this would be 1 minus 0 is positive over x squared. I'm plugging in 1 is positive, so this is positive. Then if I pick like say 2e or 3e or 4e, 1 minus ln of, let's even do e squared. That's going to be easier. 1 minus ln of e squared, because that way those cancel out, over e squared squared. On top, that's going to be 1 minus 2. That's going to be negative on top over e to the fourth, which is positive. So it's going to be concave down. You also could just realize that it's going to flip. Okay, so it's going to be concave down when x is greater than e. Kind of tricky, and you definitely have to really know the graphs of e, but or ln of x, but that's how you do that one. Next up, we have the functions f and g are differentiable, and f of g of x equals to x. This is telling me, when I see that these are inverses. So because I know that those are inverses, I'm going to kind of make this little chart. And we want to find g prime of 8. So in order to find g prime of 8, we start off with g of 8. And g of 8 is flipped. So if f of 3 is 8, then that means g of 8 equals 3. Okay. So then here I'm going to flip it back. F of 3 equals 8. We don't need to worry about this. We don't have an equation. F prime of 3 equals 9. And so then g prime of 3 is going to be, g prime of 8 is going to be 1/9. So g of 8 is 3, and g prime of 8 is 1/9. All right, next, if f of x equals 2x plus 1 to the fourth, then what is our fourth derivative? So f prime of x, we're going to just kind of look for a pattern here so we don't have to do so much, but this is going to be 4 times 2x plus 1 cubed times 2. Right, f double prime of x. This is going to be 4 times 2 is 8. So, right, 4 times 2 is 8. Bring the 3 down. 8 times 3 is 24. Times 2x plus 1 squared times 2, right? Always going to be times 2 because this is a box. Right, that's 48. So f triple prime of x. So we said 48. 2 times 48 is 96. Times 2x plus 1 to the first times 2. Right, and that's going to be 192. Right, and so f to the fourth power of x, we had 192, right, multiply the 1 down, times 2x plus 1 to the 0th power times 2. Well, this part here is all going to go to 1, anything to the 0th power, but we still have 192 times 2, and so that's going to be at 384. All right, we have f prime of x as cosine of x, and g prime of x as 1. We know that if f of 0 equals g of 0 equals 0, then the limit as x approaches 0 of f of x over g of x is equal to what? So when I plug in, f of 0, right, 0 into here, 0 into here, that is 0 over 0, which is L'Hopital's. So what that basically means is that then we're going to take the derivative of the top and the bottom. So we're going to get the limit as x approaches 0 of f prime of x over g prime of x. And f prime of x was cosine of x. So this is going to be the limit as x approaches 0 of cosine of x over g prime of x was 1. Well, cosine of 0 is 1, so our answer is 1. All right, and then we have the integral from -2 to 2 of x to the 7th plus k is equal to 16. So we got to be careful on this one because we have this plus k. So the integral of x to the 7th is x to the 8th over 8 plus kx from -2 to 2. And we know that answer gives us 16. This is going to be 2 to the 8. Right? 2 to the 8 is 2, 4, 8, 16, 32, 64, 128, 256 over 8. Or an easier way to kind of think about this, honestly, is that we have 2 to the 8 over 8 would be 2 cubed. So that's 2 to the 5th. So 2, 4, 8, 16, 32. Right? So that's a little easier to think about. So this is going to be 32 plus 2k minus, and when I plug in -2 to the 8th is going to be the same number, 256 divided by 8, we're going to get 32 again. And then minus 2k. And that answer is going to give us of 16. Now, it didn't even matter what the 32's were because they're going to cancel out. 2k minus -2k is 4k equals 16. Divided by 4, k is 4.